Hi, my name is Henry Segerman. This is Symmetric Figure 8 knot. The figure 8 knot is the third simplest knot after the unknot and the trefoil. This is joint work with Saul Schleimer and Francois Geriteau. So this is yet another sculpture which is designed in the three-dimensional sphere, the unit sphere in four-dimensional space, and then projected into R3 via stereographic projection. And that explains why there's these sort of big bulges. The tube around the knot with this grid pattern on the tube is constant thickness in S3, but because these arcs out here are nearer to the projection point, so they appear bigger. So what makes this a symmetric figure 8 knot? So this is a version of the figure 8 knot that I made a number of years ago, and it's also pretty symmetric. So you can sort of, let's see, is this the right way around? Let's try this instead. So you can see that it's sort of roughly the same shape, and there were these sort of clasp regions that sort of well, clasp around each other, and they're the same in both of these. And so you can see some of the symmetry here. So if you look down this way, then it's got twofold symmetry. So if I rotate by 180 degrees, then I get back to where I started, and that's the same over here as well. There's another symmetry you can see over here as well. So so if I flip it upside down and rotate, this is almost the same as what it was before. So rotate, flip upside down. It's not quite the same. There's a reflection symmetry that you need to do. So maybe let's do that again looking from above. So notice that there's this part which goes from bottom left over to the top right. So if I flip this upside down and let's see, rotate, then it's almost the same, except that now that clasp goes from bottom right to top left, whereas before it went from bottom left to top right. So if you reflect this across a, say this plane here, then you get the same object. So, and that's an order 2 symmetry, just as the rotation here is also order 2. So, and of course you see that here as well. So if I look down from the top, I've got this thing going from bottom left to top right. If I turn it upside down and try and rotate it around, well, it doesn't quite work. I've got going from bottom right to top left rather than from bottom left to top right. But if I reflect, then I get the same object. So that's two order 2 elements of the symmetry group. Now the full symmetry group for the figure 8 knot has order 8. So I should be able to find 3 order 2 generators. So where's the extra one? So the extra one comes unfortunately not in R3. It comes from an S3 symmetry. So if you take the equatorial sphere, the equatorial S2, then that sort of cuts through 4 points of the knot around here. And if you do an inversion through that sphere, then these sort of parts where they dip in here become these parts out here, except everything's sort of flipped around. And that reflection gives you another order 2 generator, I think with some rotation as well. And then those 3 order 2 generators total in combined give you the full order 8 group. So as far as we know, this is the first representation of the figure 8 knot, which sort of attempts to give the whole symmetry group. So this is a symmetric figure 8 knot.